Okay, A&P1 students, in this video we're going to finish up talking about the basics of osmosis. So this is where we ended before we ran out of time. We were talking about somebody that consumed a large amount of salt and some chips in a short amount of time, and we had a change in the solute concentration outside the cells. So what I'm going to do is, I drew another picture. Apologize again for the poor quality, but what I did was I kind of zoomed in on the blood vessel here. So this is showing the wall, the blood vessel, and here's some solutes. So these are representing solutes so those are solutes. I probably should make that clear. So solutes are the brown things. All right, so this is the blood, and then this is our cell, so some cell in the body. So what I've done is we've already consumed that bag of Doritos or chips. So we've already changed the solute concentration in the blood. So, and this is what we had started out with, was in our cell I just put like 5 different solutes in there. And then the blood did have 5 solutes, but then we ate that whole bag of Doritos chips. So then we increased our amount of solutes, so in the form of salt. So then we got more solutes in here. So at this point, remember, if these solutes could move, they would move across the plasma membrane from this area of high concentration to low concentration and equalize, get equal numbers on either side. But remember, the solutes do not move easily across that plasma membrane, and they only do it if the plasma or cell membrane allows them to. So in this case, it's not allowing them to. So the only thing that can move freely across that plasma membrane that's permeable is water. And so that's going to be what's going to happen, is osmosis is going to happen in this situation. And so water is going to want to move in this direction across the plasma membrane. So, and I can make sure I have it. So that's the way the water is going to want to move. Let's see if I can draw water here. Okay. So what I showed down here, this is kind of how the book uses it too, so it might make some more sense as well. So, but the reason that the water is wanting to move in this direction is because if the water moves from inside the cell to outside the cell here into the extracellular area, then it will dilute out these solutes, and then the solute concentration will decrease. And then it will equal the solute concentration inside the cell, which is what the body wants to do, is have a balance of solutes outside the cell and inside the cell. So down here, this shows the solute concentration, and we did it as a percent rather than as numbers. So typically in the cell, we have 1% solutes, and the rest is water, 99% water. And that's generally what we'll have in the blood as well, unless we ate all that sodium chloride or that salt that was in our chips. And then what happens is we got more solutes. So then in this case, after we ate those chips, we have 3% solutes and 97% water. So, and this is just all based on concentration. So just how amount of solutes in a certain amount of volume or fluid. So it's 3%. So if the water, so this is showing the water moving, if the water does move from, which it will, from inside the cell to outside the cell to help equalize the solute concentration on either side of the plasma membrane, then what will happen is the water moving in this direction, it will increase the water over here. So if let's say we have like water moving in this direction and 1% of it moves in this direction. So that would cause this to go to 98% because it's losing water. So, and then gaining water over here, so that'll also go to 98%. And then what will happen with the solute concentration is that if we're losing water from this side, that means the solute concentration is becoming more concentrated, so it'll go to 2%, because we lost water on this side. And then we're gaining water on this side, so that'll dilute this side out, and then that'll go to 2%. And so then what osmosis caused was with osmosis, the equalization of the solute concentration across that plasma or cell membrane, so between the inside of the cell and outside the cell. All right, so hopefully that kind of explained osmosis. It's a little bit more complicated than the other types of membrane transport, just because it's not moving so much to equalize water on either side of the plasma membrane, but to equalize the solute concentration on either side of the membrane. So, all right, so that was the end of the basics of osmosis. So in the next video, we'll start talking about the different environments or solutions that cells will be in, and how they will react in those particular situations that they're exposed to. So I'll see you in the next video.